One fire ranger at station A reports smoke 30 kilometers away. Oh. Does yours read better? Yeah, I don't know what happened. Like, mine has extra words. So your textbook, I'll read from your textbook. One fire ranger station at A reports smoke 30 kilometers away in a direction east 30 degrees north.
Reports 30 kilometers away in a report, smoke 30 kilometers away.
Okay. East 30 degrees north. Your textbook is better. I don't know what happened to the smartboard on this one. A second station at C, due east from the first station, reports a smoke 20 kilometers away. To the nearest tenth of the degree, determine the distance between
Just skip it.
No, it's good. It's good.
Just skip it.
I fixed it. If I just take this out, and your textbook one is perfect. So, what do we have to do? We have to make a diagram here. Here's station A. Make my crosshairs. East 30 degrees north. This is where they see the smoke. Oh, I'm going to get creative and make some smoke. Oh, nice. And I know this is 30 degrees. That's what I was supposed to get from the first sentence.
Where's our A? Is our A the middle one?
And I know that A is right here at the crosshairs. And I know this is 30 kilometers. Somewhere along this line is station C. I don't know exactly where it is. Could be anywhere along that line. But I know that the distance from C to the smoke is 20 kilometers. Is this the possibility where we could maybe get to?
Unfortunately, yes.
Unfortunately, like, C could have also been over here and make the 20. Or maybe 20 is impossible, and this is just smoke and mirrors, and there's no solution. That could be a possibility as well.
I'm gonna take an educated guess right now. Why would they have two really close together? So we should just assume.
We should
that
assume
farther
it's
away, far away.
by logic they should be further apart. That is a nice educated guess, right? Unfortunately, in math problems, they don't always assume common sense, and they're like, they would probably the best math answer would probably be this. The answer is the one to the right. However, there are some people in the world that lack common sense, and so there's also the possibility of the one to the left.
The people that lack common sense are the people that lack trigonometry.
Thanks.
I disagree. So, what do we want to find? We want to find the distance between A and C. We have to figure out if this is a possibility of two answers or not. Do we have an angle and an opposite side? Yes. We have the 30 degrees and opposite is the 20, which means we could solve for angle C first. What do we want to find? We want to find the distance from A to C, but we don't have that side and we don't have the opposite angle for that. We're going to have to solve this whole triangle in order to solve this question. Question?
Can't we just find angle C?
We have to find angle C first. Okay? So at this point, I'm still, it looks like I'm going to have two triangles, but I'm going to start by solving for angle C. So I want to solve for C, so I put that on top. Sine C over 30 equals sine 30 over 20 So sine of C equals 30, sine 30 over 20. And I'd like you to do this without a calculator. What's the answer?
Just 20 degrees,
0 point something.
0.15.
No.
No idea.
This is a non-calculator. 30 degrees should be one of the ones you've memorized.
30 over 4.
Close.
0.75.
0.75. Because what is sine of 30 degrees?
1 over 2.
1 over 2. 30 divided by 20 is 1.5. Cut it in half again, 0.75. Or you could do the 30 and cut it in half and get 15 over 20, and 15 over 20 reduces to 3/4 and get 0.75. But this would be a calculated question, because next you would say, oh, according to my CAST rule, it could be in quadrant 1 or quadrant 2. And so my reference angle is going to be sine inverse of 0.75. Go to my calculator and do that. And I get 48.59 as my reference angle. What is happening here? That's what's- And so angle C could be 48.59 or 180 minus 48.59.
139.
131.
131.301. 131.41.
Oh, I trusted you, Grisha. Last time I do that. 131.41. Do both of them work?
I hope so.
131.41 and
Oh, it does.
I can't remember, 48.59. Could they both work with the 30 degrees?
Unfortunately, yes.
Unfortunately, yes. So what that means at this point, okay, both work. And when both of them work, I like to draw two separate triangles. Because I find this looks busy with having all those lines and all those things drawn. So I'm going to take the big triangle and draw that one. There we go. Whoa. Here's the big triangle. And relabel A, B, C. This was 20, this was 30, this was 30 degrees. And I'm going to go up and also redraw the small one. And the small one's going to have an obtuse angle. You know the word obtuse for angle? An angle bigger than 90 degrees. This is still 30 degrees. This is still 30 kilometers. This is still 20 kilometers. But now this one's going to have 48.59 degrees. And this one is going to have 131.41 degrees. We have two triangles. I draw them separately. I need to find AC on both of them. So we're not done yet. Yes.
So is the reason that both of the angles work, is that because the 20 kilometers
kilometers is smaller than.
Is 20 kilometers is smaller, but it wasn't, like, sometimes when it's smaller, it's so small that it doesn't touch, right? Like, if I said, oh, there's only 1 kilometer, well, that's impossible. It's impossible to draw. Okay?
That should happen to Gaussian group.
So, what happens in this situation, we solve it like normal, we do our cast rule, we check both angles, and if both work, that means 2 are possible. It could be that it's still only 1 works if you get the perfect 90-degree one. It could be less than the perfect 90-degree answer. It could also be less that none of them work. And this is why we call this situation the ambiguous case. Because initially, when we had the 20, we were like, I think it's going to be 2, but it might swing around and be perfectly the 1. Like if I told you it was 15 kilometers, there would only be 1 answer. And if I told you it was 12 kilometers, there would have been no answers. So just the fact that the opposite side of the angle is less than the adjacent doesn't tell us how many answers there's going to be. We just don't know yet. That's why it's called the ambiguous case, because we don't know if there's going to be 2, there's going to be 1, or there's going to be 0. I can tell you most typical from questions on the exam and questions on your quizzes and tests is that they like the 2 one. They only wanted you to find 1, they'd give you a bigger one. And if there's going to be no answer, well, that's kind of an easy shortcut for you because you don't have to do as much work once you figure it out. So they don't like to ask that one very much.
What according to you is the best way of getting ourselves?
Yeah.
Okay, so from here, what could you find next?
Angle B.
You could find angle B because it has to add up to 180. So what is left here? This is 78. So this one will be 180 minus both of those will be
11.59.
101.41 degrees. And on this one,
11.59.
we're at 60, gonna be 18.59, so close.
Close enough.
Close enough. 18.59 degrees. I'm going to split my page here because I still have to find this side. Are you okay if I call it little b? Because it's opposite of angle B. So we would put that on the top. Little b over sine of 101.41 degrees equals, and here I would use the 20 and the sine 30 that I had from before. So b is going to equal 20 sine 101.41 all over sine of 30. And I can type that into my calculator. So one thing you notice is I'm using a lot of decimal places as I go because we want to try to avoid rounding early.
What would happen like on the test if it was like a question like this and you rounded?
So
and you
if
got, like 1 off or something?
If your final answer to how many decimal places they wanted is off, then you lose a half a mark for rounding early. So sine, so I kept 2 decimal places.
That's 39.2 kilometers.
$39.21. What do they want us to round to?
1 decimal.
1 decimal places, so 39.2 is this answer. Well, equals. And I'm going to go and label that on my triangle as well. I have to do this on my second triangle as well, so now it's going to be b over sine of, I'm going to scroll up a little bit, 18.59 equals 20 over sine 30. If you have a graphing calculator, I'm going to show you a little trick. Couple things you can do on your graphing calculator. One is you could go second and above enter is entry, and it just retypes what you just had, which is really kind of nice because all I need to do is change this to 18.59, and then I don't have to retype everything. That's kind of cool. 12.8. Or you can just use the up key and highlight it and push enter, and it retypes it as well. So to one decimal place, this one gives me 12.8. Make sure I include my units. Look how much work we did. We did a lot, right? If I zoom out so we can see everything.
It's worth.
Once you find out that there are two triangles, at that point I draw them both. And then I drew a line down the middle here, because now all my work for this one I'm going to do on the right-hand side, all my work for the other one I'm going to do on the left-hand side. I don't know there's two triangles until I've used my cast rule and solved for C, and I actually checked them here originally with my first diagram and like, oh, they both work. So when they both work, then you have to solve both triangles. Now in the homework, so our questions that I'm going to get you to do right now are 5, 6, 9, and 14. And 5 is, I think the textbook has done it a little bit confusing. So I'm going to just give you a note. Turn to question 5 right now. Have a look at it. They've drawn the triangles, and they're saying that their triangles are drawn to scale. And in question 5, those are obtuse angles. So angle J is bigger than 90 degrees. So you only have to solve the one triangle, but the one where it's bigger. Technically, question 5 is a two-triangle question. But if they've drawn the triangle for you and it's to scale, you have to recognize, okay, is it the small one or is it the big one? And they're supposedly drawing you the small one with the obtuse angle. So that's why they only want one answer. Technically, question 5 should have two answers and two triangles. But because they've drawn it, the answer key says we'll just do the one answer one.